Hi, everyone. My name is Ainsley. I work on the product team at Enigma. And what Enigma does, as we just mentioned, is we try to enable private computation for smart contracts. As you know, data on blockchains is public by default. That includes your transaction data, and it also includes any data that you put as input to smart contracts. And so that is something that really is a limitation on the types of applications we can build and what we can do with applications that already exist. This is the problem that we're trying to solve. So the Enigma Network, which has a network of nodes that are enabled with trusted execution environments, handles the private computation aspect of an application, and we rely on the Enigma chain for the verification layer. We currently have a discovery developer release out, and this network will be permissionless. It's economically incentivized in a proof-of-stake model. And most importantly for this talk, it's compatible with Ethereum. So you're able to outsource the parts of your contract that need to compute over private data to our network, and then call Ethereum functions from the secret contract when you're ready to return that data back to the Ethereum network. So the best way to kind of explain how that works is through the perspective of the stakeholders of the network. And that includes developers who deploy applications, users who create tasks, which is basically a unit of work for the Enigma network, and the workers who then execute those tasks. Developers deploy contracts to the Enigma network. They write these secret contracts, which are written in Rust, and then compile them to bytecode and deploy them on the Enigma network. They're registered on an Enigma contract that lives on Ethereum, and that manages those contracts. Users are able to interact with these applications by submitting encrypted data to the secret contracts on Enigma. And a hash of that data will be submitted to the Enigma contract on Ethereum so that it can be managed from there. And then once the, yes. And so then finally we have the worker who has this data now. Workers receive tasks based on a stake-weighted lottery. Whatever worker is selected is able to then execute that task and propagate the results across the peer-to-peer Enigma network. The worker also submits the results back to the task sender and optionally calls a function of an Ethereum contract with the result. After the task has been verified by the Enigma contract on Ethereum, the payment is released back to the worker. So just to review this, users are able to submit encrypted inputs, the worker executes the computation, updates the encrypted state, and then returns an encrypted output back to the user. It can also make an Ethereum callback, and that allows you to run some business logic privately on Enigma, and then return the non-sensitive result back to Ethereum for further processing. So I'll talk a little bit more about the process by which this encrypted data gets sent to the network. And so just to review this, what needs to happen is that the encryption of inputs has to happen on the user side. So we have a client library for that called Enigma.js. The worker needs to be able to decrypt that input in a secure environment. The worker needs to be able to perform the computation and then re-encrypt that data for transmission back to the user, who then needs to be able to decrypt it and read it. And so this is how that process works. First, the client requests a worker ID from the Enigma contract on Ethereum. Once that user has the correct worker ID, they perform a Diffie-Hellman key exchange protocol. Every computation uses new keys in a new encryption process. Following the key exchange, those users are able to exchange encrypted data. So that's kind of an overview of the data flow in our network, and I'm happy to go into more detail with questions afterwards, but I also find this stuff to be more clear through an example, and happily we have one of those, and we just finished it earlier this week. So this is a coin mixing demo that we made. And so just to recap, Enigma provides data privacy. So that means that any type of data that you're inputting to the contract is encrypted, but we are using that affordance in order to create transactional privacy. So as you may know, coin mixing is one way to achieve transactional privacy. It obfuscates the history of whatever transactions have happened on that account. Does this by kind of pooling funds together and then sending them to fresh new recipient addresses afterwards. We're excited about our implementation because the architecture that we have enables us to have certain advantages on both usability and on cost, and I'll get into that in a little bit. So just to recap what this project is, it's an Enigma-based mixing service. The protocol is based on CoinJoin. It's non-custodial. That means it's not a centralized service. And it's non-interactive, which means that users don't have to interact twice with the application. Once they say, like, this is what I want to submit, and here's my recipient address, they're done. Once the application finishes running, they will receive their tokens in their recipient address without any further action on their part. We also have implemented this with a quorum, which is a minimum number of participants in the mix. The reason that you want to have that number be above a certain amount is to ensure that it's not kind of a, let's say, useless process where it's just me and one other person mixing our coins, and that's not a very good way to achieve anonymity. We also will implement a time threshold, and the reason for that is because even if you have a quorum that's somewhat large, if people know what that quorum is, it's possible to spam the mix by sort of like submitting, if the quorum is 20 people, I submit 19 transactions, so I'm trying to track my counterparty that way. So a time threshold in addition to a quorum can introduce some amount of randomness there that makes that more difficult. But we haven't implemented the time threshold yet. And as you can see, there are some members of the community that think that this service is very important, and we agree. So we have a quick demo video here. I will play it for you. Hopefully the Wi-Fi works. Okay, so this is actually running right now on our Discovery Developer Network, which is a locally deployed version of the Enigma Network. It runs in a Docker environment, and we just released a few weeks ago a command line interface for it, which is an NPM package, so it should be pretty easy for you to get up and running with this developer release if you want. So it starts off, this is going to be just a little slow because it's how long it takes right now. But you can see it's kind of setting up the task information. On the left here, we have a very simple UI that kind of walks a user through what a CoinJoin is and what kind of information they're going to need. You can see at the bottom there that progress 0 out of 2. For this application, we've just selected a quorum of 2 users, which is pretty low. Like I suggested that would be a bad idea, but just so that this demo doesn't take forever, we'll just use 2 people. You send your sender address there and your recipient address, which should be like a fresh address that you've never used before. User 1 has submitted it, and something I should note right now, we're only handling fixed deposit amounts, like 1. That's so that you can't be identified by having like a very specific number that you're mixing, very specific amount of coins, for example. Now we're on the next user, user 2, who has a lot of ETH, very rich guy, very concerned about his privacy. Now they're mixing, ready to make salad. By the way, we picked the name salad because we think coin mixing should not be seen as like an illegal bad activity. It's healthy to achieve, some privacy where your transactions are concerned, especially if you're opening these wild CDPs and so forth. Maybe you don't need everybody to know about that. Okay, now it's waiting and, oh, did it already submit? Did you guys see an alert down there? No, not yet. Well, the relayer, which I'll talk about in a second, has now received all of the messages and has batched them and has submitted the new deal, and we're just waiting for that deal to be approved, which can take a little bit of time, but hopefully not that much time. Any questions? Yeah?
What exactly is Enigma? Like, is it a decentralized network?
Yeah, so Enigma is like a network of nodes that have these trusted execution environments. And we are kind of like a layer 2 to Ethereum. So we work with Ethereum by this callback functionality. And we also kind of propagate the tasks amongst the Enigma network.
And how do you verify the outputs that the workers send?
That's the purpose of the Enigma contract on Ethereum. I can get into more detail on that, but that's the reason the task the user sends is hashed and committed to the Enigma contract and sent encrypted to the network so that when the result is processed, it checks to make sure those inputs were received by the worker were the same as the user said they were sending.
No, what if the worker just submits like a random output and says this is my output? If he doesn't, that's a computation.
The computation is public, and that's kind of how the execution environments work, is that you have some trust in them that they execute the code that they receive. We can talk more about that stuff later, but those are good questions. If you want to play around with this yourself or try out our Docker environment, you can check out the demo at this address, and I encourage you to do that. But I'll also go into a little bit more detail. This should be pretty quick because we already talked about it. But basically, this is the client. And in this model, we're actually using a relayer. And so something I should mention is that the secret contracts, you can actually have, they have encryption libraries as well. So what we've done here is we've kind of double encrypted the recipient address. So the users communicated with the secret contract to encrypt their recipient address. And then they've submitted that encrypted recipient address as well as other deal metadata to the operator. And the operator then waits for a quorum to be reached, 2 people in this case. And when this quorum is met, the operator creates a new deal. And the operator is also responsible for watching the deposit contract to make sure that the users aren't lying about having actually made this deposit. That can be reverted at the end of the deal if for some reason that doesn't work, but this is a better user experience if the operator is playing nice. So when the quorum is reached and the time limit at some point in the future is reached, the operator uses Enigma.js to submit all the deal information to the secret contract. And the secret contract logic here is actually really simple. All it does is it decrypts the recipient addresses, it reorders them, and we have access to a randomness service via the TEE environment. So the addresses are then reordered, and then it returns those addresses to an Ethereum function. And the Ethereum function has an only Enigma modifier, which means that only this secret contract can actually call that disbursement function, which is responsible for then sending the coins to these happy, wealthy, anonymous users who have a lot of testnet ETH. Great. So some of the reasons that we're excited about this, and this is a very early prototype for us, just trying to explore one of the use cases that our protocol affords and explore how our architecture enables different solutions to other types of other alternative ways that you could achieve something like this. One of the things that we're excited about is cost. We don't have hard numbers on this yet, but we will soon. But we do know that ZK ZK proofs are very expensive right now. We know they're getting cheaper, and we hope they continue to do so, but that's something that we're very curious to see if we can improve on. And also the usability aspect. Like users, once they submit their deal parameters, they're not required to have a proof that they have to come back to or keep the tab open for 24 hours or anything like that. It's kind of a once and done sort of a situation. This is something that we can also do with stuff like voting, where instead of a commit reveal process to achieve a secret vote, you're just submitting your encrypted vote. Computation is being run and then the results return, and you're never responsible for like revealing your hash or anything like that. Cool. So some open questions for us on this project. What's a good anonymity set? That's the quorum number. We don't really know. It kind of depends on what your threshold for risk is and for what purpose you're mixing your coins. What's a good time threshold? Is that actually a good thing to pursue? And we'd like to enable arbitrary size deposits in the future. I think we can do that, but we have to do some further work on it. And we're very grateful to the Semaphore Society for inspiring this project and also for their research on mixing in general. Cool. So we're also excited about other applications, and we're currently working on building blocks and primitive sort of demos in all these verticals. I mentioned private voting. That's relevant for governance. We're doing secret auctions. We're really interested in things like multiplayer gaming with state, working on demos around that, things like poker, rock, paper, scissors, as well as the elephant in the room of personally identifiable information and things that are sensitive data about yourself that dApps require to function, but would be too sensitive to include on-chain. Yeah, so I was hoping that we would have time for questions, and because I spoke really fast, I'm sure there will be questions. It's kind of a trade-off there. So go ahead. Just wanted to point out, we have a forum. You can ask questions there too if mine don't satisfy you. And I'm also going to flag our engineers who are here with me. As I said, I'm on the product team. I like things to work and for users to be happy, but if you have hard questions, just kidding. Go ahead. Can the Enigma worker see his private data? No, that's not possible. Why not? Because of how hardware enclaves work. They have a private key pair generated inside of them, and the private key for that key pair is never seen outside of the enclave. The one we're using particularly is called Intel SGX. So, yep. That's what we call proof of Intel, and it's a good question. A lot of people have it, but if Intel does have access to that private key, we're fucked in many other more serious ways. It's not a bad question. It's a good question, but yeah, that's my answer for that one. Yeah, so there are some things like foreshadow and side channel attacks like that. We think that those have been primarily mitigated by Intel patches and microcode updates, but we also will have some like local worker consensus, which can help make sure that the enclave is returning the correct result, and as well as having nodes be randomly selected. So if you're going through all the effort to get access to the node and launch some type of like attack on it that requires that type of access, you're gonna not always be guaranteed to even get that task, which is why kind of having this decentralized network of nodes that do share encrypted state is actually much more robust than saying just relying on the same enclave to do all that processing. Yes, in the back. But you have to shout really loud.
Are you supporting AMD or different architecture?
Can someone repeat his question that's closer to me?
Are you supporting AMD or different?
Oh, are we supporting AMD? Not right now. I think like we're very interested in alternative things like Keystone and other types of open source enclaves, but right now this is like hard enough, so we're focused on this for now. Yes?
You mentioned quorums. I didn't quite get what decision is made when the quorum is reached, and can the adversary civil attack this consensus?
Yeah, so I'm going to try to answer your question, but I think there might be two questions in there. So the quorum is specifically for this application, coin mixing, and it's basically the idea is that if you and I are mixing our coins, and you're like a malicious actor, or it's you and your bad friend, and you're trying to clean your coins, and I'm the cops, and I send like 30 transactions, so that I'm trying to make sure that I know what the output is, and you guys don't know that you've actually been traced through that mixer. So a quorum is to try to like create enough people that participate in the mix to guarantee some, yeah.
Not M of N is just a large enough anonymity set.
Oh yes, sorry. It can be. I guess you could have a threshold if there were other factors like time that passed, so you could create something that's more complicated. But yeah, for right now, it's just an anonymous set. That's correct. Sorry. Any more questions? Yeah.
Do you know what the picture is with open source enclaves without regards to
Do I know what the picture is? Like what's going on? There's a project called Keystone that I know about. I think people are working on it, but we have like our hands pretty full just trying to get this ready and onto mainnet. So I don't know too much about what the current state of affairs is with that. I do know that Intel is also very interested in releasing a second version of this chip that will have a more decentralized attestation process. So that's also perhaps a step that you would be interested in. Any more? Yeah?
As you apprehend, you could still see your attack system. I want to track people, I just send enough transactions that I own 99% of the transactions in the mixer. I end up tracking it.
Yeah. So I think Sybil attacks on mixers is something that a lot of people are interested in figuring out a solution to. One thing that I've seen discussed is this idea of somehow incentivizing people who are holding large amounts of funds to just keep their funds in the mixer, so that it's actually like really expensive to do something like that. Because in order to get like some type of super majority of the people participating in the mixer, you'd have to commit quite a lot of money. Like, so for example, imagine that N instead of 2 is like 20,000 or more. But yeah, I think that's something that's an active research question. This is, like I said, we just finished this demo on Monday, so we're discovering all the problems now. But that's something that will affect most coin mixers that rely on an anonymity set. Any more questions? It's so great. We have so much time for questions. Okay, well, if you don't have any more questions, I'm Ainsley, Maria, Lena, Avishai. We're all going to be here, and we're happy to talk more about this. If you are interested in building something with us or have questions about what we're doing, we love to chat. Thank you.